We know what is testing, right? But what is unit? We can say that unit is the smallest testable part of the code. This video will be the first content of the test-driven development series. So in this content, we will see how we can play with the Google test, how we can build from the repository, how we can use it with C++, how we can use CMake with the GTest. So simply with C++, CMake and Google Test, we can create a unit test environment. It's kind of a framework, kind of an environment to test our code base. So first, we will build the Google test. I will use the Linux here, but if you are able to build the Google test on the Windows or on the other operating system, the other steps will be same. So because we will use a CMake, so CMake will isolate, will abstract the environment, right? The build environment. To install the Google test, first we should clone from the repository. I will not clone the latest one. So there is a release version. If you check the repository of the Google test, which is right now, this is the latest release, but in the next it can be updated, so you can change accordingly, but it's up to you. For this simple tutorial, I think this will be enough. In the beginning, I will show you how we can build the Google test, but you don't have to build it actually. Also, I will show you how we can use without build the Google test with the CMake. Also, you can directly install with the simple package manager. But my intention is to show you what is behind, what is under hood a little bit. Okay, then I just install the Google test here in the directory. So just go to this directory. Then we need a CMake. I have CMake here, not like this, I think, version. So I have this version. But I think this is the latest one. I don't know, so you check the version accordingly. Then we need to create the build directory first. Go to this directory, then run CMake here. For this example, I will disable the mocking, but we will see in the next how we can use the mock, right? I will delete this directory also later in the following minutes. Just don't worry. Now configuration is done. Related files are generated. Then simply we can run the make file here. So what we have now here, we built the Google test, as you see, with GTest and GTest main. So without mock right now. For our first example, if you go to the lib directory, or let's go to the build. We are in the build lib directory. Let's ls it directly. So here some static files, libgtest and libgtest main. So we can bind this static objects, let's say, so we can directly call the related functions from these static libraries. I will go back here, then I create some, let's create example CPP, code example CPP, and I will simply include first a stream. I don't know, maybe we don't need it, but I have no idea now. So then we will include GTest header. We will also give the path of these headers during the compilation. This will be a simple hello world example first, right, for the unit test. So using name space std, I don't know we do need or not. Normally, we need an int main, and we need to pass, let's pass for the arguments, argc char double pointer. Then we need to initialize the Google test, which should be like this. Init Google test. Then we need to pass the same arguments here. And we need to run the all tests with the return. Actually, we don't need this, by the way. We don't need to implement here with the main. I will show you in the next. With the CMake, we can ignore these things. But for the first time, it is a good idea to understand this. Then let's write some simple test. Example test. So it's kind of a macro, right? Test one, let's say. So we will check just simply, I don't know, 1 is equal to 1, right? It is just a simple assertion test. So I save it. Let's go to the terminal here, and with the G++, example CPP, Google test, build lib. There, as I told you, there is a lib test static library. So we we need to bind this libraries simply. So for the other one, we need another one here. Main, yeah, we need to main also. We need to have main build lib test main static. Okay. Then we need LP threads for the compilation from the command line. If you don't have this, then you need to install it, the threads. Then we need to give the path of the include files. Simply it is in the GoogleTest. There should be another GoogleTest. Interesting, then include here. So we can compile it, but this should be run all tests. I will make the mistakes. Now we have binary, right? Then when you run this binary, as you see that we have one test here, which is this one. It passed, right, as expected. So this is really the hello world. Let's say the hello world application, hello world unit test application with the GoogleTest. Well, we are not using the unit testing every time like this, right? This is one of the way to use this unit testing with the GoogleTest, but this is just a simple test. So what if we have, for example, with a class, right? We are using the object-oriented programming. So what if we have a class example? Let's try to implement some tests with the class, some example object, I don't know. Let's make some function which returns 1, and we can check instead of 1 here. Of course, we have to create one example object instance. Example x and x foo, right? We can call it like this from the stack. So let's try to compile again and run the example. Let me clear this screen. So it passed again, but if I want to add another test, for example, like this, and I want to test, for example, this one is returns 0, but I want to test it's not equal to 0, right? So this is another way of using this, not equal. Let's compile again. But yeah, the test names should be different, as you see here. Test 1, test 2. This can be same because these are the tests, like a namespace, right? If you give another test here, for example, then it will be compiled for this example. But there will be, the example test. So these are, as you see, these are the different tests, different like a namespaces, different bunches, right? Different bunch of tests. So just we run 2 tests here to our pasts, but as you see here, we create two times with the example instance. This is not necessary. If we can, we can make some kind of the global definition like this, but it's not a good idea also, right? So we need a kind of a way to encapsulate everything in a single test class with our test object, our dependencies to be mocked, for example, right? This is a good way. So I just want to show you in the beginning. Not much people use this, for the simple applications maybe. For what I told you just before, which is called Excel text fixture, test fixture. Okay. So this should be the fixture should be implemented like this, for example. And we can make this example as a fixture, but let's do this different way. So I will remove this. I'll create another class, which is named test. Let's give test fixture. Okay. So then we need to inherit this from testing test like this. So what we are going to do, we need to, we are inheriting a class now. So that means we will implement some functions. So this is just a class. So we can have a constructor, we can have destructor, and more functions from the GoogleTest, from this testing test class. One of them is as a void setup. It should be like this, if I am not wrong. And the other one is tear down. These are, for example, this setup. When we will create a test with this fixture, with this class, this will be called first setup, right? Before the constructing the object. Why? Because maybe we need to set something before the test, before our object can be. Then text fixture constructor will be called. Then if the test will finish, then the destructor of this class will be called. Then at the end, the teardown will be called, right? There can be some cases, for example, we cannot throw an error in the destructor, so we can check in teardown, for example. I don't know. There can be many cases. Then to use this, the notation should be like this. So we should put the name here. So this to test belongs to this class anymore, right? So also for the fixture, we should do this underscore f. That means fixture. So we don't need to create any more the example like this for each test case. We can simply create one time in the class itself. So for example, let's do it in the pointers. It's not a good way, but for just an example. So this can be created, new example, and the constructor of the test fixture, right? So that means, for example, when we will call this test fixture, when we will call the test one, this constructor will be called and the new example instance will be created. And these steps will be same for the another test cases. This part is important because, right, for each test case, we have new instance. We have new instance to test. This is the point of the test fixture. So for example, we can let's first try to run this. So of course we have to change this. I gave just quick introduction with the GoogleTest, but we will go a little bit for these things in the following minutes of the tutorial. So I think it's okay now. Let's try to compile. Yes, another problems. 32, I forget every time stupidly these semicolons. Again, what happened? I think I need to put public here also. I forget the public. Okay. So by the way, all examples that I'm going to show you here exist also. Under the video there is a link, you can find them. So when we will run this binary, the output of our application. So as you see, test fixture test 1, test 2 just passed, but we have every time new instance to test. So we can check like this, for example. Let's put some text here. A newly created test. We can check also the order, right? Destructor. Okay, let's put some constructor here. Setup down. Let's see now what will happen. As you see, for each test case here, for example, for the test 1, const will be called first, right? We create a new instance with a new. Of course, we didn't delete something here, right? It's not good, but don't worry about it now. So then the setup is called. So we can use it in the next. So then teardown is called, right? I think I made a mistake. I told that destructor is called, right? First constructor is called, setup is called, then the teardown is called, right? To check is something bad or not. Then at the end, the destructor of the fixture will be called here, as you see. So for each test case, we can follow the same steps. For each test case, the constructor, setup, teardown, and the destructor will be called again and again. This is the point of the test fixtures. So this is very basic usage of the fixture for the GoogleTest. But as I told you, we are using now the command line here to compile the GoogleTest, to compile our binary, to compile our application. But this is not a good way. So we can create some CMake txt. So what we can do now, we can do the same thing for the binding, right, with the CMake. But this is also not nice. But let me show you first what I'm trying to say. By the way, I can do it, right? Can close it. CMake minimum version. I will put a version here with the 3.10, but I will show you why I did this. Actually 3.14, I think, but it's okay. Let's set the CMake standard. 6x standard. 6x. We can give the name for our project, example gtest, but this one not here, right? This one should be removed. Set CMake standard. This is on 14. This should be like this. Then we can include directory, right? So we can directly copy here. I just did the same thing. What I did before via command line is the same with the CMake here. Then we can add an exec table, the project name, not like this. This is a global variable. When we set here the example gtest, it will be set here. So we will simply bind the example CPP. We don't have any other CPP or header files for this simple example. So then we need to target to link our binaries, libraries actually. Again, project name, CMake source directory. We can use some variables from CMake source directory. Now GoogleTest, I can copy it here, I think. Then I will do the same thing for, I think I can do this like that. So I just bind the libgtest static library. Then I will do that also for the libgtest main. Okay, looks good. Then we need to call thread, right? We call from the command line lp thread. For which we should do this with the same with the CMake. That is it. Let's try to compile it. CMake. Let's compile here. Couldn't find a lot of file. GoogleTest include. Yeah, I forget to add directories here. Directories. So it should be include underscore directories. 6. So let's run again. So configuring is done. Generation is done. Okay, so we have a make file now. Okay, we run the make file. We run same test again. Same results. Okay, so as you see, we can use CMake. We don't need to use command line, right? When we have another CPP file, we can add here. But the question is, should we bind this static libraries like this? It's not a good, right? This is dependent to static library. We have to build again. So no, there is another way. There is another way to bind these libraries without caring about them, simply. To do that, if you go to the CMake the website, there is a fetch content method. So this fetch content can fetch the data from the repository with the static libraries or whatever they have. So we just simply give the commit number, the release, for example, like this commit number. Then, for example, this is for GoogleTest. Yeah, it's a nice example. So we can fetch directly without building it. So we don't need to build it. We can fetch it directly. So CMake, CMake gives us the ability to fetch the GoogleTest binaries without building it. To use this, we need again these things here. This can stay, but we don't need anymore these. I think we don't need these things. Okay, we need to include the fetch content. So this version, let's check the version again. I forget to check the version. So it says new in version 3.11. So at least you need this 3.11. So now we have 3.10, so I will make a 3.11. Then we can include the fetch content. Then we can declare the fetch content here like this. So this is the Git repository. This is the tag, the commit number. You can give whatever you want. Then this usage is like this, the fetch content make available GoogleTest. So we need to now until now, that you need to care just the binding now. So we need to add executable again, like we did. So we need to bind the main and for example, GTest main and GMOCK main here. So we will also use the mocking. So we can use it now. We can target like this. Then also there is one improvement here. Okay, let's first try like this. First, let's remove the GoogleTest. We don't need the GoogleTest anymore, right? We built the GoogleTest. We have static libraries inside this directory, but we don't need it anymore. We fetch it directly from the repository. So remove it. Then let's try what will happen. Make clean. And also we can remove the CMake cache list, cache tags, TSD. Then we can call the CMake. Form is found quite fast. Nice. So now we can run the make. So you see that it built the GTest. Also it built the GMOCK. So we did this before, right? Manually, but we don't need to do this anymore. So then we can run. Oh, but this one is the this is the old one. So our new binary is example GTest. So same. So we are able to run the unit test application unit test binary without building the GTest. Actually, we build it, but via CMake. Now we don't care it, right? We don't care how to keep it, how to store it, the binaries. So CMake can handle this simply. And one more improvement. This is nice. So we don't need the main for our unit tests. We can ignore this, and to ignore this, to not to use this run all tests, we can use simply the command the gtest discover tests. like this. So we need to include first GoogleTest, then we can use this function with the project name, which is the example G-test. All tests will be, will be found automatically. We don't need to run or init the GoogleTest. This is also the nice part. So let's try. We change the CMake. Let's run the CMake again. Yeah, let's try to make. As you see that it's compiled and all tests run. See, we don't have a main, but it worked. Nice. So that means we don't need main. This is nice. Now, what we did simply from this until now, what we learned a little bit how we can use a test fixture, right? In this way, we learn how we can include it with test, how we can use with the CMake here without building it. We built in the beginning, but we understand that it's not necessary. So we understand the idea of the test fixture, right? That setup, tear down, and the destructor and the constructor. So we can encapsulate the tests, the unit tests of the example class, right, in this test fixture. So we encapsulate everything here. This is the point. So if you ask yourself, what is unit tests? This is, what is, okay, we know what is testing, right? But what is unit? Unit is we can say that unit is the smallest testable part of the code. For example, the foo method of the example class. Foo method of the example class. Foo method can be testable from the unit perspective, right? This is one unit. In the example class, foo method is one unit. So we can test this unit like this with the test fixture. So example instance created here. So in this test, one unit test will be tested. The X foo method is tested. Okay. So it's quite a simple hello world application with the CMake, right? Also we learn how we can ignore the main, and we learn how we can fetch directly from the repository. So now let's make a little bit things more complex. So because there's no fun here. We will check the GMOCK example now. We create some dependencies between objects. Okay. So to do that, this is quite messy right now. So I would like to delete all things here, but I'm not sure it's a good idea or not. Maybe we can keep the CMake list. Then we can keep also the example CPP. Okay, then I deleted other files and directories. Okay, so before let's create some directories to keep it, everything in an order, kind of an order, let's say. So we can first create some source directory to keep our CPP files, because we will create some interfaces, right? To mock. Mocking means, you mock some kind of an object. So object needs an interface. Can be, it doesn't have to, but in this example, we will create an interface. Actually, okay, let's create another the directory for the headers, include, and let's create the test directory to keep the test file. You can change them, right? You can change the directory names or the tree here. I will put the CMake list here, same, but the content will be probably different, so we need to add the include source and test. What we're going to do. So here we need to add our CPP files here, add executable. When we have under the source directory, and we need to include, we can include it, I think somewhere here. Include directories, include. Okay, so when we create the CPP files, we will use here add executable with also our tests directory, but it's okay to put the same, but you can isolate if you want, you can abstract it. So now before start, let's talk the idea via UML diagram. So we will here, as you see, here we will have a dummy class. We will test this dummy class. Okay, this dummy class has an relationship with the interface, one interface, which names is foo interface. So foo interface implemented by the foo. Dummy use this interface, right, to access the foo's method, which is foo string. So there will be a method in the dummy class which calls foo string over the interface. So to test this, we need to create the fixture, test fixture, like I told you before. This test fixture will hold the instance of the dummy object, and also at the same time test class test fixture will hold the mock of foo object. So this part is important. So we will not use when we are testing, we will not use the foo itself. Why? Because this is the unit test, right? I told you unit means the testable smallest code part. So if we will use also the foo method during test, this will be not the unit test. This will be something else, because we will test, in this case, we will test the two methods. It's not what we want. We want to test only the method of the dummy class. So that is why we need mock class to simulate the method of the foo object, right? So that is why we don't need to have an interface every time for the mocking system. But for this case, to explain clearly, interface is a good idea. Interfaces are good actually. Use the interfaces. I like the interfaces. So then in the source directory, let's make dummy CPP and include dummy HPP. Then let's first implement these things. Dummy CPP. Okay, let's put dummy HPP here. Let's save them. I think it's a good idea first to implement the header. Let's just show the header here. So we have guards simply, right? I think for this example it's not necessary, but it's okay. Let's add it. Then we will have class dummy as a public. It matters actually, right? For this example, I will keep everything as a public, right? But it's not a good idea to do these things, but we are talking about the unit testing now. So I create a simple constructor here without any injection, right? So, but in the next, we will inject a class here, which is called a dependency injection, right? Why they code like this, I don't know, dependency injection. People are asking during the interviews sometimes, what is dependency injection? So it is just simply passing an object. What is it? So let's have a method which returns integer. I don't know. Let's keep it simple. So dummy int, for example, this can take a string like this. Let's make it const. I cannot keep myself, not happy when I see the string not constant. It makes me not happy. Then, okay, let's give some name here. But I think we can define this in the CPP file, right? So also let's include the string to not have compilation errors. What is the problem? There's no breakpoint here. And so simple constructor and simple method. Looks nice. In the implementation, we should simply include the header. Then dummy int method. I don't know. I'm not good at giving names. You can give some fancy names. Std string. So this can simply return the size of the string size. Okay, really simple, right? So let's write unit test for this dummy class and also for this method. Let's write a test fixture for this. To do that again, we need to create test dummy CPP, let's say. We can keep everything in a CPP file. I think it will be okay for now. We need to include some headers again. So create a class, for example, test fixture dummy, and like we did before, public testing. We need to inherit this from this class test. There should be a constructor, setup function. We will not use this, but I'm just typing here to make you, aware these exist. Tear down. This S should be bigger, I think. This is capital. So now we can, for example, let's include also memory. I don't want to use the naked pointers, so I like to use, for example, a unique pointer for this example. Unique pointer. What was our dummy, right? I just forget our name of the class. Dummy m, for example, test dummy. So now this is just a pointer. We can create here std make unique dummy. We don't have any dependency. Okay, looks nice. So what we have now, we can remove this example CPP anymore. We will not use it. What is this remove? So dummy CPP here. We have dummy CPP, dummy HPP. We will test this class in the test dummy CPP file as a test fixture. Let's try to compile this first. Maybe we can have some, problem. So this should be source dummy CPP test dummy CPP. We don't have any tests, but I expect this should be compiled at least. Then to compile this, I'll create build directory, right? Then I will go in the build directory. Then I will run the CMake inside this build directory to keep everything inside this build directory, right? To not make a mess like what I did before. So it looks from the CMake perspective is okay. Make file is generated here. Then we can run the make. It will build again the GoogleTest main GMOCK, but it will be fast. Looks okay. So now we have example gtest. We can run it, but there is no test, so it says passed, 0 tests, false positive. So now we can, for example, create a one test fixture, one unit test for the dummy. What was the name? The dummy int method. So this should be the test fixture dummy. Let's give a dummy int the name of the test, and we have a already pointer, right? Already the instance, so we can call it directly. Dummy int. But also we need some kind of string. Let's use the parentheses to initialize. Let's give something, I don't know. So I like to print my name. So string. So we can say result, but this will be not unsigned. That's okay right now. This is also returning int, but it should be unsigned is okay. String is a whatever. So we can check assert equal result should be same with the string size, right? Because we are not changing anything, just returning the string size. Let's we don't need to run the CMake again. We need to just run the make. Yeah, there is some problem. Yeah, okay. I forget to add a public here because then it will be the all things will be the private. We cannot initialize the fixture. Let's run again. Looks okay. Let's run our binary unit test binary. So okay, it runs and okay. So now again, this is a little simple, right? Okay, let's make it a little bit harder now. Go back. So then I will create 3 files. Foo if let me check first, and include foo if hpp, okay, and foo hpp, and source foo cpp. Looks okay. One interface and one object itself. Da-da-da-dum. And now foo interface. Let's put here an interface. So let's try to to code the interface first. Again the guards, so we can have the foo if. Let's give the foo if the name of the interface. So this should be, yeah, it can be, it depends the situation, but I like to now for this example I would like to keep this interface a pure abstract, right? So this is why I like to create pure virtual function. So I create the same idea, foo int, which can take the string, can be const. Let's keep the signature same. So I like to put here the string then. Okay, so then we need a foo. This foo will implement this interface. Again headers. Then we include foo. No suggestions. Okay. Foo if hpp. We need to include string. No, we already include in the interface. Then we can start to declare the class, right? Also which inherits the interface foo if as a public. Well, as I told you, you can check, you can change these things to see the effect. So I will keep still public everything. If you inherit the pure virtual class, let's say, if there's a pure virtual function in the abstracted in the class, in the interface, that you have to implement it. So that means we have to write down, but of course the signature should be same. So string simply. Okay, let's implement this in the CPP file. I will put here this, and in the CPP file foo hpp we should include, and let's implement our simple foo int method, right? const std string. So also this will simply return the size of the string, nothing more. It's just the same. But here, okay, here. So that I told you, right? Let's make the things are a little bit complicated. So then let's put a dummy header here. So in the dummy object, we will pass the foo. Let's do it in this way. Include foo or foo if, right? We need to, yeah, it's in interface will be a better idea. So we need to interface, we need to object foo object in the dummy class. It's not a composition, right? It's an it will use the dummy will use the foo object and foo, let's say like this. So in the constructor we need to inject this foo, you know, because this is a reference initialization. So we need to initialize it in somewhere. Otherwise we cannot compile the code. So then foo if we can take it with a reference again in the constructor, or let's use like this foo f. What a great name, right? Okay, foo, let's say like this foo, or okay, I will keep it. I don't care. So what we will do, what I just did, I just simply inject the foo interface, foo object, right, from the constructor of the dummy. So now we have a dependency. Then also I need to update the dummy CPP here, but I think I don't need to. Okay, I will not create anything. I created the constructor also here. It's okay. Let's keep it here because the constructor is empty. But it's not a good idea. It's okay. So then we can simply implement this, right, for the foo int, for the dummy int. We can change the dummy int. We can use like this. So I will remove this here. So I will call the foo object. Come on. Foo int method and passing the string and waiting the answer, right? Asking the size of the string that I just passed here. So now we have a dependency, and if we are able, if you want to run this the test now, the unit test, you will see it will not be compiled, right? It's not possible because we changed the constructor, we changed the signature. Okay, then let's go to our tests. So now we need here dummy foo class, right? Foo object. So this is the point. This is the exact moment that we need mock. We need mock class because we will not pass the foo itself here. We will not do like this. For example, foo f. For example, we will not do this, or you know, like this. We will not do this because then we will test this function also, right? But I don't want to test this. I don't want to call this function for the unit test of the dummy class, right? I don't want to run this function. But it's a little bit weird maybe, you know, if you don't play before with these things, it can be a little bit weird. But this is the way. So we will not run this function. This is the exact moment we need mock right now, because we have a dependency for the foo. So we will pass here mock foo. It will be like this, for example, mock foo. It will be like this. We can do like this. I don't know. Not like this, right? Not m here. M foo, for example. So then we need to create code in the header. Let's put it in a header. Mock foo HPP. You can put the guards again, but it will be okay for this example. Foo if we will include the interface. So then we need to, or before this, GMOCK header, we need to include the GMOCK, right? Because we will create a mock now. Then I think we need also, I think we don't need the string, right? In the interface, it's already included. So then mock foo public foo if I inherit again the foo if. That means we have to implement this function, right? It's not like this. This is a good way. You don't have to inherit. You don't have to extend any interface with the mock actually. But for this example, I created an interface, right? But you can have some kind of template function without an interface. So you can create directly mock without like this, without using an inheritance, without extending it. You don't have to. But for this example, we use like this. That is why I create interface. That is why I also extend this for the foo, mock foo. So, but the implementation is a little bit different for this. So there is a notation. It should be like this. That we will create a macro again here. So mock, it's not a const, right? No, okay, mock method. Now first we need to give the return type, which is an integer. So what we are doing simply now, we have this function in the foo, but we don't want to call this function. We don't want to call the foo itself. We don't want to call this foo itself. Instead of this, we are creating a mock object which extends the interface of the foo, right? So this should be same with this function, in this macro. So first we need to give the return type, then we need to give the signature string. Then we can say that this is override, right? We override it. Okay, so there is a mistake. I made a mistake. This should be also the name foo int. Okay. So now we can call mock foo instead of foo itself in the test, our test fixture. So we can include mock foo HPP. Okay, let's try to add this to the CMake list. Let's see if there's a problem or not before implementing in test, but it will not be compiled, right? So we can directly pass this now. Then we have source dummy. We need source, what was named for CPP? Actually nothing more, right? The includes are here. The others just include a header file. So, and also test dummy int string. This will resolve. Okay, then we can understand better now. Let's try to compile. Let's see what will happen. I don't know because I'm a little bit lost. We changed the CMake. Nice. I will remove this build first. Okay, I will create this directory again, but I didn't need. I could simply remove the CMake cache, but yes. Okay, and CMake. I will run CMake like this, and make. But of course, first we should go to the build directory. Okay, this gives some errors. Dummy does not have any field name in foo. F will be capital. Jeez. Okay, we don't need to run anymore the CMake again. We can run the make, and I forget again and again. Foo if, no, not foo if, right? Foo HPP. How I just forget it here? The semicolon. Interesting. Another const. Oh my god. Foo CPP3. This should be const. Okay. Then let's try again. And I typed also the name of the mock is not correct. Yes, mock foo. I think also it's still not correct. Should be, let me copy it. Oh, I don't want to record the videos in the night. So now, yeah, it's compiled, right? So we have test now. But as you see, that's failed, right? That's a good idea now to analyze, to a little bit check what is it without we just inject now the mock for the foo, and we expect, we just run the example with test, and we call the dummy int method, and this dummy int method normally calls the foo int, but we create a mock, so the mock method should be called, right? So then if you check here, it says it's failed because it says, see the function call. There is a function call, uninteresting function call here. And also which is 0, which is 9. We didn't call this function, right? So this, as you see here, it's failed, right? It is normal. Because we have to tell to mock, this function will be called and then return some result, which is the mocking. So we are able to control, we have a full control of our now mock function, mock method. So we can do whatever we want now, for instance. So now the usages should be like this. So we have another expect call, another macro, which is called expect call. So we are now expecting a call, which you can see simply here, right? We just run the test, so the dummy int test, and it says GMOCK warning. So uninteresting mock function call. So it says there is a function which is called, but in the test there is no function call here in the test. So are you sure that it's warning? So this function also it calls the number of the the size of the string. So but we didn't write anything here. We didn't simulate the method. So that's why the test is failing. Then we can simply create the expect call. So we expect call. We expect this function, actually not this function, but this then the mock function, right? We expect this function should be called. So expect call foo, which is mock, which is mocked object. Then foo int method. So we can, what we are saying here, when we call this function dummy int method, when we call this dummy int method, so which function will be called? We know that fooInt will be called from our mocked foo. So the parameter will be same, the argument will be same, string. Then simply, we can also use a wildcard here, like this, for example, to pass everything. So it means don't care the arguments. But let's do it. Let me show you the difference to understand the difference. So then what should be done here? Okay, this is it actually. So then should be how many times should be called? One, just once. Then also will once. This should be return will once. Let's extend here a little bit. Testing. Return. This should be return string size, right? So test. Actually, it's string size, like this. Okay, let me check again. Is there any problem? So what we did, we have a mock. We have a mocked of foo class. So we expect that from this mock class, we have only one function right now. We expect that when we will call this dummy int method, we expect that this function, this fooInt, should be called with the parameters, with the argument string the same, because this will be passed here. So and it should return called once, and it should return return string size. This is the usage. Okay, so now we simply simulate the function. This method will not be called. If you put here some cout to be sure, just type something that this function will not be used anymore. We never use this in this example. I just want to show you. Then, okay, let's try. Let's see what will happen. Let's compile again. Okay, there is no problem. Good. So let's try to run the unit test. So now still failed, but I think I made a mistake. Yes, I think I made a mistake. Yeah, this is also a nice point. I made a mistake here. This expect call should stay before the function. Otherwise, it will not expect how we can expect it. So this is a good exercise, to understand. So then we have an expect call. We put it here. Now we expect when this function will be called. We expect this. Let's make again. Let's run. Ta-da! It's just passed. Nice. So this was a nice example, right? Also, we learned that we should put this expect call before the functions. Nice. So then what we can do, actually, right now, let's summarize what we did to understand better. First, we create a dummy object, right? Dummy class. In the beginning, dummy class has no dependency to anything. Then we simply create some test fixture, right? With test fixture for dummy class. And we simply create our test object with the unique pointer. But at that moment, there was no dependency. Then we made a little bit things too complex. So we create some interface, abstract interface, which has a pure virtual function. So then we implement this with the foo. We extend this interface with the foo class, which has a fooInt method, right? Then we inject this foo from the constructor of the dummy object, dummy class. Nice. That means we create a dependency. Now we have a problem because from a test perspective, unit test perspective, because we don't want to test another class. Just we want to test for this fixture. We want to test only dummy object. So now we have a problem. That means we need to create the mock object of the foo. So we created the mock foo HPP, and which inherits the foo if interface. Interfaces are important also. It is one example. If someone asks you what is the usage of the interfaces, so you can give this example for the unit testing. This is a good answer. So we create a mock class. We learned that we should include the mock header from the GTest. So then we use the mock method macro to create kind of a simulated method, right? To call, to check, to play in the unit test. So for example, I can create another test. So dummy int2. Let's give another weird name, dummy int2. So this can return, for example, not string size. I want to return something different. For example, 12. Which is not a string size, right? Not the size of the string. I want to return 12. So, but I want to test my function. I want to unitly test my dummy CPP here in this function. What will happen? If this function will return something weird, what will happen, right? I want to test this. This is the unit testing, right? So I have a full control of this object now. This is really simple. This is really simple function, so it's hard to see. But if you think that there are a lot of things are going on here, let's assume. So there are a lot of different objects. They are dependent on each other. They are returning different values. There are some cases, algorithms, blah blah. So we can control all of them, right? So I return here 12. So I expect not to echo, right, to this size. Okay, let's expect this and let's see what will happen. Let's make again. As you see, one test failed, right? As it is expected, which is 12 and which is 9. It says result is 12, but string size is 9. They are not equal. So the test should be not equal test. This is the point of the unit test. So now they passed. So we can create another test also, right? We can create another countless tests to check the behavior of the dummy int method using our mock, right? Nice, very nice. For instance, we can make more examples until now. I think this is more clear, but there are a lot of different macros, right? Different measures, for example. You can check on the internet. You can check these things. There are a lot. I cannot explain this video. It's already more than 1 hour. But we can add some examples, more examples, to see how we can play with, for example, I don't know. I can add also to the repository. You can check from the link. But let's try to not return from the function. Let's try to pass, for example, let's try to return directly from the arguments right here, the string. So what I mean, simply, let's start from the foo if. I like to create another abstracted, pure virtual method, foo string, for example. Let's make it not const for this video. And okay, this is const. We can do the same thing with this actually, but this is okay. Why I pass here the reference, I don't know. But let's not make it I don't want to make you confused. So I just pass the string as a reference here. So I like to this right now to implement this, right? First in the foo HPP, we need to create again another function. So this is a nice practicing actually. So when you add something, when you add something to code base, when you change something, it is high probability that you can break something in the unit test. It's not like a integration test. So when you change something in the code, be aware that probably you will change also the unit test. It's so high probability. But for example, in the integration test, for example, if you don't touch to the functionality, then you don't need to change the integration test, right? But if you change the function name or adding a new function, then you have to change. You have to add more tests. You have to change the unit test also. You have to update the unit test. Then foo HPP, we should go to foo CPP. Let me foo string void string. This will return nothing. Okay, this can return something. This is not const. So for example, we can populate the string here. We can example string, for example, example string. Okay. So when we call this function, this string will be example str. Okay, simple. Then let's do the same thing for the dummy HPP. The same idea. I just want to show you, right? Dummy string, std string, and let me put the dummy CPP here. We should simply define the foo string for the dummy here, and we will not, we will do the same thing. We will call the foo string from the foo object, so we can pass here. So at the end, we will expect that we will have this example str string. So we can test this now. The only difference is here, as you see here, that this function does not return anything. So what will be the difference? The usage of the macro expect call macro will be different, right? So the string will be passed, and we don't expect any integer, but we expect a string from the argument. So we return arguments. We return from the arguments. Okay, let me compile. Maybe I made a mistake, as you see. Full string dummy CPP 8, because why? This should be dummy string. Yes, this one is a good example now. What I forgot now? I forget to add this function to the mock object, to the mock class, right? Because we changed the interface. See, we changed the interface, but I forget to change. I forget to update the the mock class. So it's a nice example. It says, guys, there is a full string function here in the interface, but in the mock foo there is none. So you have to put it there, right? So let's put it. This should be void. This should be full string, and this not const anymore. That is it. Let's make again. That is it. Let's put it. Nice. We can run. We didn't add any tests. So now let's add a test, unit test for this dummy string. Mock foo. I need to also, I think, check this. I don't remember it now. This is the only part here. Foo int. This should be foo string, right? We need to foo string. I'm just updating quickly so we don't have a result. Okay, what we will check, the string itself. Nope. String itself. Okay, I will update here. Let's make it comment now. So then this should be will once times 1. There is no returning, so we can remove this. Will once testing return string size. This should be not correct, obviously. Testing. This is the way to return from the arguments, right? With reference. So testing set arg reference. Referee 0. Yeah, this should be 0 now for our case. Return string, but this is not a return. It's a string. Okay. What is going to do here? I mean, what will be happening? String will be returned. When we call this function, string will be returned. So what is the point where we are testing here? Why I did this? Okay, so because string will be different. So there will be result, right? So we can put some std string. So string, this one will be overridden. Okay. Result string, which should be example string, let's say example string, and I expect that this should be equal, this should be same, right? So let's share again. The test dummy will call the dummy string the function which should be under the unit testing. So we expect from the full mock, full string should be called with this arguments and return will once from this string, and this string should be equal to result string, or we can put it directly, but it's okay. So let's try. More expected. Yes, this is a problem. I forget to remove one parenthesis simply. Failed. Okay, which is of course, but right, this is also a nice problem now. Okay, I will stop after this function, this example. We passed the string, but there is no function, right? You cannot expect that you can expect from this macro that this string should be changed, right? Okay, that means this will be not the same. So string, so this will return, for example, result string. Okay, result string. Actually, that is, we don't need asset equation here, or do we need? We don't need asset equation. Test string, or we can do like this. We can create some test string, which can be empty, and result string, which can be example string. Okay, And test string can be passed here. We can pass test string here, then test string, then this is okay. Okay, I made a mistake. Then result string, test string can be equal to result string, right? Because it will return result string, expect call, then this will, okay, this will be equal. This is, I think, correct. Sometimes also you can write wrongly, the unit test. Yes, this is correct. So what we did here, we create a test string, empty one. So yeah, now it is working. It is different than the previous one. We have a result string, so we return the result string from the argument. So it's here. It's okay. It is okay now. So we pass test string. It's okay. So for example, we can do like this. We can also, this is a wildcard for error. That means don't check the argument. Whatever it's passed here, don't worry. So we can run again. See, there's no problem. That means it's passed. So for example, we can, so there I cannot show any way for this, I think, but it's okay. So you see now there is a wildcard also. You can put the wildcard if you have any problem with the arguments, for example. We can have, I have an example I can show you in the following minutes. And you can use the wildcard. For example, we can check another test. Let's check. Let's add another function to interface. Okay. Actually, I will keep now. I will add some function to tests together. So I will be a little bit quick. No, okay, let's not be quick. Virtual void foo. So then I will let's test throwing behavior. Foo throw. Let's throw something and let's see how we can test it with the GTest. And also let's test callback functions. Callback method, let's say std function. Let's call some void, some kind of an empty function, void callback. That means we need to include the functional. Okay. That means we need to declare these things in the foo CPP, foo HPP, sorry. Like this, foo throw and callback method. Then now we will implement these things in the foo CPP. But for the sake of this example, right, we are not using these functions, right? I just want to show you. So I just add some empty function here. So I will not throw anything here right now because we don't use it. But we will throw this in the mock. So also I just create a callback method here. So this will pass the std function, and the std function, the callback function will be called. So it is okay. It's a nice example. Then we need to, let's not make the same mistake. Let's first update the mock. This is for the foo throw method. This is for the std function. Okay, looks okay. So let's try to compile because there can be a problem. Let's be sure before proceeding. Okay, there is no problem. Nice. Then let's add same methods in the dummy HPP like we did before. We will just call the same functions with another, another object here, another class. But I want to show you the dependency idea from the unit test perspective. So simply there will be two more methods here, which will be the dummy throw and dummy callback. Then we need to implement these things, otherwise we cannot test it. So go to dummy CPP, then one dummy throw function which will use the foo object's foo throw function, right? This is the point, like these things. So also we will create another function, another method which will call the foo callback method. At the end, this callback function will be called. Then I will show you how we can test this. So then let's go to the test dummy CPP. So we will add another test now. For this, let's test first the throwing example, throwing tests. So there are a lot of ways for this. Then I will create an action using the action macro. You can give a name, throw error, for example. Another mistake, small. Then let's not write something, but I will just throw std runtime error. and I like to express something here, error test. I don't know, maybe we don't need right now, but let's write something. Then need to create another test fixture. Test fixture can be text fixture dummy, name throw test. There can be an expect call, one expect call, that we expect this function will throw. That is it. So to do this, first, we need to, there's another macro, assert throw. When you test throw error throwing behavior, you need to use this macro, assert throw. So we need to mtest dummy, we need to call the function. What was the name? Dummy throw. We have no arguments for this function. Then we need to runtime error. So what we are doing is we are checking assert throw. So this function will throw, and this is equal to runtime error or not. So we are here already throwing a runtime error, right? So what we want to use the mock. That is the idea. That's why I want to show you. So expect call and foo throw, not foo throw, right? Foo throw, the name foo throw, right? Okay, same. And this will once throw error, for example. This action simply. I don't remember there is a parenthesis, right? There should be parenthesis here also. So let's check now. Let's make. There is another info. I made the same mistake, right? This should be info. This should be info. There is a semicolon here again. So let's run the binary. So it's passed. So see, throw test, we call the function, and via the mock object, we are able to throw something to test our dummy throw function. Nice. So this is one of the way. There are other ways also. You can create directly a function, void function, for example, throw error. So you can do this. There's an example in the repository for this. So you can create directly the function itself, for example. Then you can call the invoke like this. Okay, let me do it. So instead of here, will once throw error, testing invoke. We can call, for example, testing invoke throw function. So this will call the function, I hope, if I didn't make a mistake, but info, this should be info, right? Okay. So let's run. See, this is the same. So we print something here. So you see that this function will be called, and the error test, the runtime error is thrown, and same. So there is another way also. There are more ways. I shared these things in the link. You can check. So let's try also the callback test. This is the last one, but not last for the test. I will show you also the line coverage. So test. I create another fixture now. Info, not test fixture dummy test callback. So this will be the callback callback testing, right? We can create testing. This is a bit tricky. Test mock function that I just want to show you. There are, of course, there can be other ways. So we create another the mock function here. See, the mock function to be called test function. Let's say. So expect call foo callback method. This should be called. And this part is okay. I know this is why I just directly write here the wildcard here. So we cannot pass the test function here because the callback function is expecting a SD function, right? But we cannot pass this here because this operator, the equality operator, right? This is equality name of this operator, right? I don't know. The compare, it's a comparison operator there. The comparison operator for the SD function is not cannot be used to compare two different or same SD functions. This is just a use to check it is equal to null or not. So we cannot use this. If you use, then you will probably see the compilation errors that I don't want to see it now. Then times 1. Okay, let's go down. Will once testing invoke arguments. We will call, we used this, right, in the previous, one of the previous example. So we just call the arguments, the function. So now also one expect call, you know, the itself, the function itself. So you can do like this, call. There's one more parenthesis, of course. And of course we need to right now call the dummy function itself. Call the function, test function as std. Yes, this one as std function. So this will call this mock function as an std function. Then this will be the expected. And let's see what will happen. If I didn't make any error, there's another one. One more, I think. Oh, I forget one parenthesis. Okay, nice. So let's try. That's passed. Simply, as you see that you can, for example, simulate. You can mock, you know, the std functions also like this. It's quite simple. It's effective. So guys, that is it here. Until now, we cover a few different cases. Also, the mock idea. What is it? The idea behind the mock, we understand, right? When we have a dependency, we need to mock it to test our class, our real class, to test it, right? Our unit test. This is the idea. So I will show you quickly also the line coverage, how we can do it, because it's also quite easy. So what is line coverage? Right now we are testing the two different CPP files here. Actually, not two different, one CPP files, and we are not testing the full CPP, right? So this full CPP has 0 coverage because we are not testing these things. Dummy CPP has 100 probably line coverage. We can see these things with the CMake. It's quite easy. The steps, how you can do that for the installation, it also exists in the link. Don't worry. So you can just simply read. To install the tool, so you can simply install install Lico. This is the name of the tool. I already installed here. We will use the CMake again. I have an example, completely working example here. Then I just want to copy here. Okay, so I added some lines now after here. So what I did, I add a custom target. So for example, this is the target for the make. I will show you. So make Gecko, when we run this make GCUV, then we will create some coverage directories. So then, for example, this is the also the LCOV also exists. So you can check here, but simply, okay, let me go back again, remove XR build. So let me find this command to generate everything. But I'm not sure these are the correct file source. I think it's correct. So when you when you run the make now, okay, so then for instance, as I remember, we should run first. See, this is a target now. I put the make GCUV is here actually, is in the CMake. This is target, so we can run from the make, but there is a problem. We need to run the example test. Okay, I think I updated here. I updated accordingly. So you can find the same, this script, CMake script in the link. So now we have, you know, make, so we can run make Gecko. So as you see, it creates some files and checks the lines. So this is not human friendly to see for our eyes. So we can run the make Gecko. If you check here after this, it says the functions, you know, 50% lines, 47% because we didn't have the fixture test cases for the full, right, full CPP. So then here there's a G coverage and the L coverage. So if you go to, that's with one of your best web browser, so Firefox, L coverage. So there should be an index.html, not this one. Click to index.html like this, then you will see a web page that you can monitor the line coverage. Let me make it small. So you see under source, so there is a dummy CPP and full CPP. As I told you, we didn't create any tests for the full CPP, but the dummy CPP, there's a 90%. Why it's not a 100? Because of this. Interesting, because we throw here, right? We throw here, so this line cannot be tested. Sorry. Guys, that is it. So thanks for watching again. Until now, we cover the text fixture, the unit test, the G test, how we can build the unit G test, but we see that we don't need it. How we can use the CMake with the G test for the fetching and also for the line coverage, and also we make some tests to understand what is the test fixture and how we can use the mock, how we can, what is the relationship with the dependency and the mocking. We understand these things, I hope. So if you have any questions, if you have any points to be improved, just tell me. You can reach out to me from LinkedIn or just leave some comments. I will be really happy to accept and give an answer if you have also any questions. See you again.